Hey everyone, my name is Martin Oyo and welcome to Martin Oyo, the weekly not known. So today I'll be taking you through a challenge I worked on last week. It's on 2D arrays. So if you want to work on similar challenges, I'll leave a link in the description of this video for the HackerRank 30 days of code. So the context of this challenge is given a 6x6 2D array like this one below, is supposed to define an hourglass to be a subset of values with the indices falling in this pattern, like in A's graphical representation, where you have A, B, C, then D in the middle, then E, F, G. So you can think of this as a 3x3 grid, where you have A, B, C as the first row, where D is the second row, and E, F, G as the third row. So there are 16 hourglasses in A, and an hourglass is a sum, and an hourglass sum is the sum of an hourglass's value. So in a nutshell, what this problem is you need to find all 16 hourglasses in the 6x6 array, get the sum of each, then print out the largest sum of all. So as an I'll illustrate I'll give you an illustration of the 16 hourglasses and how to get them. So as you can see here, we have our 6x6 grid, and every 3x3 grid represents an hourglass. So as you can see, we have like all the grids that can be found within this particular 6x6 array. That we won't be moving to the 5th row or the 6th row, because like you can't get a 3x3 or an hourglass from those ones. Basically that's it. The thing you'll notice is that we only have like 4 hourglasses column wise, so in each row you'll be moving 4 times. That's what the algorithm that I'll be showing you will be doing. Okay, so before you can see, like, the task is calculate the sum of every hourglass in A and print out the maximum hourglass sum. So the input format shows that you'll always get like a 6x6 grid. So there are 6 lines of input, where each line contains a 6 space separated integer describing a 2D array, describing 2D array A. A value of A will be inclusive of this particular range, so -9 to +9, which means that we'll be expecting negative numbers within our 6x6 array. And then the constraint, they help you know what to expect as values, i.e. the largest values and the smallest values, the range that complements the input. Cool. And then the output here is the maximum sum, so this is what we're supposed to print out as our output. I'll be explaining my code next. So here what we have is, so I initialize like a max result here. So max result basically is the one that will be holding the final answer, and then we start from row 0. So like just as I explained in this particular grid here, we have all arrays start from 0, so we'll start at this particular row 0 and get all the 3x3 grids that are in this particular row, all the hourglasses that are based on the first row. Okay, so here we'll see that we have, while row is less than len -2, so this one takes care of the fact that we won't be needing the last 2 to make a 3x3 grid. So need to get every 3x3 array. So for I in range 4, to represent the fact that we'll be getting in each row, we're getting 4 hourglasses. So we set the result to 0, so this result here represents the result of each hourglass, before comparing it to the max result that will be holding the final result. So then we come here and say for J in range 3. So this J in range 3 represents the fact that each hourglass contains 3 rows. So when it's 0, that's the first row of our hourglass, like where we had, like in this case where we had A, B, C. When it's 1, it's this one where we have D. When it's 2, it's this one where we have E, F, G. So for I in range 3, if J is 1, it means that if we're in the middle if you're in the middle row, what we want to is to get only the middle, like only get like the middle digit of our hourglass. So here we have our array. So this is the array that I took in as input, and then a row. So starting from like the 0th row, so starting from the 0th row, and then the J, then you come to J. So this J here, as I said, this represents the row in our 3x3 grid. So when you say array starting from this, it means that our array, when it's at this particular column, so because we need to get, because the first hourglass is based on the first row, so when it's starting from the first row, I want to get the second column. For this case, that's the second row here, and then we do some splicing here. So we have I, which was 0 all the way to 0 plus 3, so to represent that we're getting like this entire thing here in the middle for this case, or something like this. And then we pick 1, which means you're only taking B now, we're taking D. So that's that, and then you add that into the result. And if it's not 1, that means it's either the first row of our hourglass or the last row of our hourglass. It means you just take the sum of everything. So if it's this one, you take the same from the row which you're in, and then you take that particular column and everything else in it, and then you sum it all up and add it to the results. So this one will be repeated for every single hourglass here. So basically this is where the hourglass sums are being built. So for the first hourglass, for the second hourglass, based on row 0, that way it will continue just as this image showed us here. So it will do the same thing over and over and over again until we get to the last row. Okay, so what's happening down here? So if I is equals to 0 and row is equals to 0, which means that if you're in the first row and we're in the first hourglass, what we want to happen is set the max result to result, because we want to compare the results of hourglasses and not the max result, which was initially 0. So that's why we're setting max results to result here. Otherwise, what will happen is max result will always remain to be 0. If you only had this line, if the result was, if we had a negative number, a negative output, like a negative sum, it means that max result will never be updated. So what we want to do is set the result to the first one so that we can compare like sums of every hourglass instead. Yeah, so we do that, we set the max result to that. This only happens once, and then other times it'll just say max result. You take the maximum between the max result and the result, and then afterwards you increase the row by 1 so that you move to, like in this case, you move to that particular row. You do the same thing over and over, move to that row. Next thing over and over, move to the 4th row, and you're done. Cool. And if we run this, let's submit my code and see whether we actually, yeah, you can see that all the test cases are passing, so my implementation is correct, I believe. The time complexity of this code is O of n squared. So this probably means that it's definitely not the most optimal solution to the challenge. So I'd love to see what you guys come up with, and do take the challenge, post your solutions in the comment below. And if you'd like a tutorial on analysis of algorithms, there's a link in the description of the video for that. As a reminder, if you haven't subscribed yet, hit that subscribe button, turn on notifications to be the first one to get our latest weekly content. Thanks for watching, and I'll catch you on the next one.